broadcast. I forgot to click the broadcast button. Well, that video will be missing a bit. So right here, we add these two numbers together and return their value. Here, when I run this, we end up with 25. If I just call add together and I don't reassign the value of 1, I end up with 4 because I'm just saying 2 times 2 is 4, because this passes 1 into add together and 2 into add together as the second value. And then returns the 2 multiplied together in the end. And there was a little bit of confusion around variable names between functions. Even if these share the same names, that does not matter. I can do this here, reassign that value, reassign the variable the value of 1 and 2 added together. It's still going to give me 4. Why in the same way on this line, if I reassign 1 to those values, to the add together and then multiply the result, I end up with 25. The key concept here is that when you call a function from within another function, you need to use the return value. You have to assign a variable to the return of your other function call. So the walkthrough of how these numbers work is 2 gets passed in as the value. Then here, 1, which currently has the value of 2, is passed in. And 2, which currently has the value of 3, is passed in. So then we go to add together. So this currently has the value of 2. This currently has the value of 3. We enter what's called a new scope within this function. And we say to reassign the variable 1 to the results of adding 1 and 2 together. So you end up adding 2 and 3 together, and you assign 5. So 1 is assigned the value of 5, and then we return that value of 5 from this add together call. Now in this line, we say 1 is assigned the value of the result, or the return value, from add together, which in this case, as we worked through, is 5. So 1 is assigned the value of 5, and then we take 1 times 1, which is 5 times 5, when it runs through here, which is why we end up with 25. Are there any questions around function calling and functions calling another one and using the result of another function? Oh, I clicked the wrong button. There we go. Okay. Live stream is better. I think it's up and running now. You're welcome. So are there any questions around functions and the return values and using them within your code? We've been doing it the entire time. Each time we make a call to print and we have a function inside of it. It may not have been obvious because we're not using an intermediate variable most of the time that we're calling print around a function call. Print itself here is also another function call. All right, I will assume that means that was crystal clear and there's no confusion. All right, so I'm actually in this example going to fully show the 12 times 12 times table that was in the assignment. Well, not really the assignment, the work through. for the examples. And part of, so I'm going to say up front, the reason I did this in a way that may seem inefficient by repeating the same list twice, I did this on purpose so that I can show you how the got covered ever so slightly. The left pad are just the justified text works so that you can have your list come out and arbitrarily look nice. So these are multiple functions. Get rows, get columns, and if you've worked ahead, I actually would not have done any of these functions if you worked ahead to the list chapter. If you have not, that is totally fine, which is why I wrote 3 separate functions here. So I'm gonna get rows, I'm gonna get columns. All they do is they return the number of rows. Get max width. The purpose of this function, it will return the, we'll call it the widest given a multiplication times table cell should be. But we'll return that width. That has, so right here, something that may not be obvious because the width that I want is actually just the number of characters in what you multiply. So what I'm doing here is I'm saying multiply the 2 numbers, which in this case I'm always going to, you'll see down here, I'm using a built-in function called max later. Don't worry about that yet. But I'm passing these first 2 values, multiply them together, and I turn it into a string. And the reason I do that, so to give a better example here of seeing that, so if I say I have number 1 is equal to 10, number 2 is equal to 30, multiply these 2 numbers together, what I'm going to get is 300, which is not quite what I want because it's not they're not 300 characters wide. So whenever I make it a string, you can't quite tell the difference, but the real reason is so that you can call length on it. You get the length of the string, which is 3. Because what happens here, if you attempt to call length on your numbers, you get a type error because an integer does not have a length in Python, which is why I make it a string, so then I can get its length and know how wide to make the little cell of the times table. And this is another example, sort of I did it before up here with this temporary value, using what they referred to in the book a few times as a temporary variable. I could do all of this in one line, but that's a lot harder to read. So I favor using this temporary variable, and I suffixed it with the str to indicate that it is a string. So highest value sort of as a string. I take the length of that, which is going to return an integer, and then I add 2, as my comment says here, to make it a little bit wider so that I have white space kind of on both sides of my times table. So it appears as if there is white space on both sides because it will increase them all 2 on their right side, which will push all the other ones out. So the reason I defined this get rows and get columns was so I could have my rows and columns and then get the maximum value out of each one. Max If we come over here, and it's not going to show over on the other screen, just the Chromecast. So same as always with these built-in functions, if you just search for it, switch to the version of Python you're using, zoom in, max here. So max returns the largest item in an iterable, which is what we covered. Strings are iterable, lists are iterables, which just means it's a collection that holds stuff and you can keep getting things out of it. What this function does is it says, I'm going to get the biggest item out of your collection. So it's a really handy function whenever you know you're going to have a list of things, you just want to get a value out of it that is the largest. Max will return that largest value. Has some other parameters you can pass it, but right now I don't care about those parameters. So here, call max. This will, in these two cases, return 12 and 12. Pass them in here, you get 12 times 12 is 144, and this determines how to get the maximum width. And then this is an example of going over the iterables that are created up here in my get rows and get columns. So the first thing I do is I go over every row, and for each row, I go over every column, and I take my output, which I declared up here, hidden away from everything. I'll go down here so you can see it in context. I'll take output. I initially assign output to an empty string, so this is a pretty common pattern. If you know you're going to have a string, you're going to keep building on it and making it bigger and bigger. You take your output at some point and you assign it the value of output plus whatever you want. And that is important. To think about here. So say I have some string and I assign it a value, and I go and I print that string. As we would expect, that string's value did not change. However, I can come in here again and I can say this is equal to another value, and when I print it, you'll actually be able to see it. So some string is reassigned. So this is an example of reassignment, which is what's happening every time you go to sort of increase the length of a string or add more characters to a string. You're not actually assigning more characters to a string because strings are immutable, which is what we covered on Monday. You cannot change a string. You can change the value a variable has. So what happens here first is I say I have some string and I assign it the value of a string cow. Print out that value. You can see it here. The next thing I do is I take that same variable, some string, and I assign it the result of some string plus town. So in this case, some string is assigned the value of cow plus town. So then we print it out and we get cow town as the new value of some string. This pattern is very common whenever you want to build up a long string, which is what I'm doing down here. When I take the output, I initially set the output to the empty string because it's possible I could have no rows or columns. So then I don't add anything to them. We'll just have empty output. So what happens here is I take each column in row. I go through each one of them. So I got the rows, got my columns. I define my maximum width. So down here, I'll actually create another little variable here, which will be, I'll give it a better name. I don't remember what this is. Yeah. We will call this, we'll call multiple. That's the word, but product as a string. So you can see I take the row and the column value. So in the first case, it's going to be 1 times, we get 1 for our rows, second for loop. We go in, first column value there is 1. So we end up with 1 times 1, take that product string, and then we go and add the current output at that time, which is going to be the empty string. And concatenate it with the product string, right justified by the maximum width that I defined up here. That just so the table has a nice layout at the end whenever it prints the result. So I go over each column. So the next time we go over the inner loop, you get 2, and you get 1. This will have the value of 1. This will have the value of 2. You end up with 2. Assign it. Take the result of calling the product string with R justified with the max width. Take the result of calling that method on the product string and add it to the output, and assign output the result of having added output and product string together. So what's happening every time we go through this for loop is output is getting entirely reassigned. That variable is given a new value every single time we go through this loop. So we end up going through this loop 144 times because we have 12 rows and 12 columns. So we're going to go through this outer loop 12 times, and for each time that we go through the outer loop, we're going to go through the inner loop 12 times. So what happens is within here, the output is reassigned 144 times. The number of times it's happening isn't what's important. What is important is that output is getting reassigned. You're not modifying the variable in place, you're reassigning it. The result of its current value plus another value, which in the case of strings is called string concatenation, which is what the book covered on Monday. And then the output, I did this just so you don't end up with all of it on one line. So I mentioned you have the new line character. So whenever you have a string and you use the little backslash, that's how you end up getting what they call special characters. In this case, it is the new line. So as an example, if I just do this a few times in a row, you end up with all this extra white space. New line is just that blank space. So for each row in the times table, I go through and add a new line character so that at the end of that row, you can go and see the next row start on the next line. So if we go and execute this, you end up seeing output here that shows 1 through 12 and 1 through 12. And as you would expect with the times table, you get the 2 times 2 is 4, 2 times 3 is 6. And that works because of the way that we are iterating over the values in rows first. So we go and we put each item in our row out. And then for each, so we go over each row. So we'll start here first. And then we multiply it for all of our columns. And then we go to the next row. We multiply out for all of the columns. So now if I go up here and I add 3 more numbers to my rows, this demonstrates that the rows keep growing, but I'm not adding any more columns. So now I have a times table for 15 times 12, all the way up through there. So now if I go up through 19, I think that's what I need to get to. I do not. I want it to be longer. So I'm going to cheat really fast. I'm going to make this be 25. And I'm going to range starting at 1 through 26. So you end up getting the 25th. You start at 1. So this goes through 25. Okay. I wanted to show, now I realize why it wasn't, is that the width gets larger and evens it out as you get more, because as we get further down in here, we end up with 4-digit numbers because of that max width and that right justified. So because of the right justify call here, giving it the maximum width, what that does is it pads it with white space characters. Change these back. What's the base of what's desired to be there? Just to show sort of what that means. So this is actually going to be easier to tell if I do left justification. So the reason I did right justification is so that these values, as you go down, line up, and you can easily compare them. So you can tell it was increasing. So if you were to go and try and make a spreadsheet for something, the right justification is nice. So you can read the numbers more easily. Are there any questions around how any of this works for generating the times table? I'll assume that's a no. And we will move on to iterating over a list of strings. And as a bonus, if you pay close attention, this is a large hint at some work that you might have to do later and possible ways to solve it. So you can iterate over a list of strings as well as a string itself. Both of them are iterables. So what I'm doing here is I'm, quote, translating the word. I'm not really translating it. I am masking it into something else, which the book actually talks about. Sort of a way, it's a very unintelligent to encode messages just by doing character substitution. So what I'm doing here is I'm translating it by doing character substitution for the sentence, the quick brown fox jumps over the lazy dog, which I believe has every letter in it, which is generally used, it's a sentence that's generally used if you want to view how different typography will look, like if you're writing something in Word or you're making a web page and you want to see how each different character looks. This sentence is used a lot. So what I do initially here, because I've only defined my new alphabet, which is what I'll do my mapping on, I've only defined it for the lowercase characters. So you'll just have to trust me that all 26 characters are here. They're just not in the same order they would be if you did A to Z. And then what I do here, and this is something I sort of want to reiterate, as you write code and you make functions, you should always take into account what someone could give you into your function or what someone could give you into your entire program. Say if you make a website or if you make some other software where you need to read input from a user, which is almost all software. I go over and I normalize the words. And the key there is I make all of the letters in those words. So for each word in my words up here, I go and make it lowercase. So I start at position 0. That is the first position in a list, is 0. So I go through and I say, all right, I'm going to go over all my words. So I get my first word in my words, and I say, all right, take that words at position 0. So I want the word at position 0 of my words, and I want to assign it the value of my current word that I'm iterating and taking out of this list. I want to make it lowercase, and then what I do next is I increment by 1 the value of position, so that each time I go through here, I know I'm grabbing the next word correctly from my list of words. So first iteration through this for loop, what happens is word is assigned the value the. So I say, all right, take the element at position 0 in my words and assign it the value of the made lowercase. And then now take position and add to it the current value of position plus 1, which in this case will make it then equal 1. I'll come through again and I'll get quick. Word will be assigned the value quick, and I will say, all right, I want to assign the item at position 1 in my words list the value of quick made lowercase. And I keep going over each time, increasing this so that I know I'm always reassigning each one of these values in here correctly. So each time I go through, I reassign the position of the words list to a new word entirely. It just so happens that I always assign it to the lowercase version of the word currently looking at. That's to normalize it. Now later, I do a very similar for loop. It's a little bit more complex here because this is where I'm actually going and replacing values. So I have an index, set it to 0. Do not worry initially about what this means. So as you know right here, when I do words at position, I can reassign it a value. The reason I need to use list and create a new list, what this does is it creates a new words list. So if I just had some words here, and I print words, I get 1, 2, a list. Now if I do this, print out the same thing. Now if I go and I reassign that first one, both of them are changed. That's why I need to call list. That's as far as I'll go with this here, because this will be covered in your next reading. But that's why this little call to list here happens. It's so that I get a brand new copy of this, the quick brown fox jumped over the lazy dog, that set of words. So I get a new set of words here. So for each word in the words, the quick brown fox, I'm going to initialize my new word. So I have my word index, which is at 0. and I have my new words. And the new words are going to be the translated values. So I know that when I'm, quote, encrypting this we can look here and we know that T should be replaced with wherever T falls in the alphabet, is going to be somewhere around, I think, M. So A, for instance, will be replaced with L, and B will be replaced with I. So that's what's happening. That's the goal of what I'm going to be doing in this section of code. So I go over all the words that I already have, just like I did up here. But I'm no longer going to be changing those words. What I'm going to do is I'm going to be setting new values to my new words that have not yet been encoded in the new translation language. This is very similar to some work that you will need to do, which is why I wanted to cover it. So I initialize the new word, as my comment says. So take my new words, I go to that index at 0, and I assign it to the empty string. So this is the same pattern that I did up here, where I take an output, I assign it to the empty string, and as I go through and do something, I keep making it larger and adding more length to it, making the string bigger. So same concept here. The only difference is I am doing it to the location in my list. So I'm saying whatever position word index represents right now, I'm saying take that word in the list. So the first time through, it's going to be saying, all right, assign it, the empty string. And then what I'm going to do next is I'm going to say for every letter in my word, so this is the example of iterating over a collection within a collection. So words is a collection of strings, and a string is a collection of characters. So what these two for loops do here is I go over the words. So for each word in my list of words, I then go over each letter in that word. Which is my comment says, I go over and I start to set up my new word in the list of new words. I go and create my new word. So like we covered on Monday, ord goes and returns the numeric value of the letter. And because I have this list up here, the new alphabet, it only has possible indexes of 0 through 25. So I can only get each one of these letters by saying get the letter that is located at the 15th position. And if you recall, when you call ord on one of the lowercase letters, you end up with a higher value than 0 or 25. So what I'm doing there then is I'm saying, well, I know that's going to be 97. So if I just have some other letter and I subtract it, I know that works. The reason is because if I go and I print the ordinal value of Z has a higher ordinal value than A. So I know no matter what, A is the smallest one, which means if I go and I take the ordinal value that A has, it will be 97. I know every number greater than 97, if I subtract 97 from it, I'm going to get anywhere from 0 through 25 for these numbers, A through Z. And the reason I know that is because go to the ASCII table. This is not a good one. There we go. So if we look at the tables and we see these lowercase, we'll zoom in a lot further. I know that these are all sequential. So it starts at 97. Always going to be, those ordinal values are always going to represent a character between A and Z, inclusive, meaning it includes A and Z. So back to the example here. What I'm saying is the new position, new alphabet position, which will be the position in my new alphabet list. I'm saying I want that position to be whatever my current letter is in this word. So for the, it'll be the lowercase t, minus the ordinal value of lowercase a, and that will give me the position, which will then be which letter I want to have translated t into. So then so the same thing I did up here, I started with the empty string. I'm grabbing that same in my new words. I'm saying to take it and assign it the value of adding itself and whatever the letter is at the position in my new alphabet list. I do that for every letter in the word, so I'll do that for T, H, and E, and that will be a new word, and I'll be done with the words in the first one, so I'll be done with the words in the, so then I come in and I increase my word index so that I then move into the second position of my new words. So in the same way up here, where I did the normalization, and I went and reassigned it that value, the next time I come through here, I'm going to be using the word quick. So my second time through, this will be quick. Word will have the value quick. Now we'll go over each letter in that word. So I'll go over the Q, the U, the I, the C, and the K. And for each one of those letters, I'm going to determine its position in my new alphabet. And I'm going to create a new word. Starting with Q, I'll determine what that new letter should be. It gets added to the empty string. So then I have a new letter there. We'll say it could end up translated to T. And then I go to the U. And at that point, new words at this current word index will have T. And then I will say, all right, assign this whole variable the value of T plus what the new U will be from the word quick up here, because I'm going over each letter in the word quick. So once I finish with quick, I increase the word index, and I keep repeating those steps until I exhaust all of the words I have. And then after that, I print the existing words and the new words. I will zoom out, so it'll be difficult to read there, but the reason I've zoomed out, so you can see it on that TV, is that you can see the change that happens here is that T becomes J, H becomes P, E becomes F. And the sort of a spot check way to verify this is we know A becomes L, and B becomes I, which means we should start with Li in the new alphabet that we defined above. So that's sort of a spot check to know that the letters got replaced correctly. And that's why I printed out the original set of words. P is currently at the 15th position, which I printed that out just as an example of how to access the values. Does anyone have any questions here around what this is doing before I move on to the default parameters and functions? Or if you just want to shout at it because you don't like it. I'll always assume silence means it was perfectly explained. Flawless. So because I was trying to come up with both a realistic example and a short example to demonstrate how default parameters work, it is a little bit more mathy than most of my examples. But I wanted to show one reason you might have a default parameter, as well as what you would do in the cases that that value changes. The only reason I use math here is because I wanted to represent infinity. And you can't represent infinity in almost any programming language unless you use a special constant or variable. So in Python, that is in the math package that we've used. And it's called math.inf, and it represents infinity. The only reason you would really use this, you can't really use infinity. You can't really multiply it by other things or add it. The reason you would use it is so that your program would see that it got an infinity value and know either something went wrong or you know that whatever you're using isn't going to end. So in this case, I defined a function, divide by x. So if you tried to divide by 0, I just say that's infinity because 0 can go into things an infinite amount of times. It's mathematically inaccurate, but we'll say for this that dividing by 0 means infinity.
So can I do a for loop, a range from 1 to math.n?
I don't believe you can because it is not an integer. You can try it. This question was, can you do a for loop? So if you import math and you try to do a range through infinity, if this does work, it'll be unfortunate. Yeah, so it's represented as a float. So it can't be interpreted as an integer, so you can't range over it. So I created two functions, each with their own default values. So times x, which will take a value that you pass in and multiply it by x. If you don't pass the second value, it's an optional parameter because it has the assignment already taking place within the start of your function here. So x will be 10 unless you pass another value. And in this case, x will be none. So just so I can talk through these. So in this first case, I take 10, I didn't pass another value. So you get 10 times 10, you get 100. The second time I passed 5, so you get 10 times 5, that returns 50. divide x, I use the, it's none, which is representative. You can think of it as something does not exist. What it actually means is its value and type are both none. And none is often used to represent something not existing. It's used a lot as a default parameter in functions so that you can determine behavior based on what they call. So in this case, if someone says divide x and they don't pass in a value for x, they just pass in value, what's going to happen is I just return 0 because they didn't say what to divide. Divide by x. So in that case, I don't know, so I'm just going to say it's 0. This next case, this elif, if they happen to pass in 0, I don't want to go and attempt to divide by 0. I could remove this. What happens is you get a 0 division error because you're not allowed to divide by 0, both in real life and in programming. Which is why I chose to say that dividing by 0 means infinity. And then the final option is to just say divide the two values, and you end up, in this case, 20 divide 10, you end up with 2. In the other case, where I actually checked for 0, return infinity. This is another example of always trying to handle what are called edge cases, when people pass values into the functions you define. So, for example, in the is prime assignment that's been turned in, you might have had some trouble because you didn't try all the different possible primes that they initially put in their test cases that your code ran against. Which leads me, does anyone have any questions around the default function parameters? Yes?
So if I didn't pass anything in for x and I didn't set x equal to none as the default, x still be none?
No. So if I go and say I define what I'm going to call broken, I'll call it broken times, called x, y, I don't assign a value. I say x times y, return that. I get type. Then I go to print out, broken times, and I just do 10. What's going to happen here is this error is a type error because all parameters, unless they are assigned a value to start with, are required.
I got to check for x equal to
No.
none.
So if you don't, so the question was, can I not just check, in this case, equals none, let's say it would be 10. That is still a type error because this was called a function definition. The function's name is broken times, and it has two parameters, a parameter named x and a parameter named y. All parameters in Python are optional or required. By default, every parameter is required. So every parameter in a function, so for every variable you define in your function, it is required unless you've gone and explicitly said it has a default value. So in your function definition here, this is a function that has a name divide x and two parameters. The first parameter is required, and it's called value. The second parameter is optional. Its name is x, and its default value is none, because you said that x equals none. Well, x is assigned to the value none. in your function definition. If your function definition does not contain an assignment, every one of your parameters is required. Any other questions? Oh, yes.
On the pre-divide x by 20 over 1 parameter, why does it 0? Because it should be 20 over 9.
So it doesn't, because I specifically, so the question was, why does 20, the divide x here, where I pass 20 and I pass 0, and the result here is 0? The reason for that is because in my function, I specifically check that if you attempt to divide by 0, it returns infinity. So the value that returns 0 is divide x here. So to maybe make this a little easier, let's list the number of parameters passed. Each one of these. So in this case, I pass 2 parameters, 20 and 0, and it returns infinity. And that's what I print out. The reason it's returning infinity is because I specifically said if I pass the value 0 for x, so what happens when I call divide x here is it goes and says, all right, value is assigned 20, and x is assigned 0. Then it comes in here, and it says, is 0 equal to none? That's false. And then on this elif, it says, is 0 equal to 0? That's true. So then it immediately returns math.inf, which inf here is short for infinity. So then it goes and returns infinity. I could have also just returned the string infinity there, but since everything else in this function was returning an integer or a float, I wanted to keep it consistent. It's actually generally a good idea if you have a function that usually returns the same type. So if you have something that always returns a string, try to have all of your return statements return a string. The exception to this comes around with none again. So it's very common for functions to return none. Because they may not be able to do so. So if I wanted to ensure that what I'm passing in not be lazy. I want to ensure the things I'm being given are both integers. I can check that, and then I can say to multiply them. Else, I can return none. So here, if I print out x times y, say 2 times 4, and I comment out my broken function so that it's so you get 2 times 4 is 8, because they are both integers. The 2 values I passed in are both of type integer, which is what this check does here. If you remember, we ran type a lot initially in the first 2 weeks. A reason to do this is to keep your program from erroring. So if I don't do this and I just immediately return x times y, in this scenario it's fine, but if someone decides to go and pass something like that, it errors because none cannot be multiplied by an integer. So this is why a function would return none. So what would happen in this, what would normally happen in this case, so you would call, and this prints out none because it is none. Normally what you would do is you would assign it the value here, and you print it out. But in cases where you may not be sure, so you've written a long enough program and everything is stored in variables and you don't know at that point if your variable is assigned a value of a string, or it's assigned a value of none, or it's assigned a value of a float. So here, I go and get a return here. So then I can say if the type of product is none, otherwise, I can just have it print out product. We'll learn about this is operator on Monday, but this is why you would care about returning none. So the other thing you can do here, or to not introduce that, so then if the type of your product that you have is equal to the type of none, then you have no product. And this is done a lot in programs when you use what are called third-party libraries. So when you use someone else's code, you can't ensure every time that what they give you from their function that they created, that it always returns what you want. So oftentimes you'll go and check and validate, oh, that did do what I wanted, so that's good. So an example of why you might return none is to indicate that you were unable to perform the operation requested. So in this case, what you're saying is I wasn't able to multiply none times 2, so I just returned none to you as the caller of my x times y function. And this last little bit that I wanted to cover before we go and get started on the studios is testing your own code. Well, hopefully everyone, oh no, I cheated, good. I didn't actually give a real implementation of is prime, just in case they're not all there. So test values, very similarly to in the Runestone book, everyone's been using that from test import test equal and running it. Python actually has a way to test equality built into the language. It's called an assert statement. So if you just say assert and you give it a Boolean expression or a Boolean value, comma, whatever your message is. So I also wanted to show an example of using string formatting, which is covered in the reading for today. So what this function does is it says, all right, is the first value equal to the second value? And if it's not, it will raise an assertion error. So all those errors that you've been seeing whenever you go to submit your Vocarium assignment and it says some error occurred, assert will raise one of those errors. So you've probably seen an indentation error. Up here, we saw the type error, trying to multiply the wrong types together. Here was a syntax error because we weren't passing the value in. Another type of error you can have is what's called an assertion error, which is specifically done whenever you try to assert a Boolean expression. So in this case, I'm asserting that my first value is equal to my second value. If that's false, it raises an error and the program stops running immediately. So in this case, the second thing here, so you do your Boolean expression, comma, some message. And the reason that that message is there is so that when it gives you the error, you can have a message with it to tell you what went wrong. So in this case, that message is going to be whatever the first value happens to be is not equal to whatever that second value is. So what I'm doing here is I'm creating a temporary variable called failed message, assigning it the result of calling .format on this string here, which .format is in the string package. And there's a whole bunch of documentation around these little curly braces, and how 0 here means the first element over here will be used as that, whatever makes the string, and how 1 will map to this second value, and the parameters that you pass through are called the format. So I have my isPrime function. This is me trying to cheat, and instead of having an isPrime that actually checks to see if it's prime, I just check to see if the number you passed happens to be in some of the things I know are prime. And I just return true. Please don't actually do this in your assignments. But if you wanted to cheat a little, you could just try and put as many primes as you could find in there and just return true. And return false in these other cases. So then what I do here is I go and create a whole nother list of primes separate to my application. So this is an example of what Vocarium might be doing to your code. And it says, all right, so for all the primes I have that I know are prime, I'm going to go and test that you, so is prime, which returns true or false, that it's always true. Because I know for every one of these integers in here that they are prime. So a call that is prime for each one of those integers should return true. So what I'm saying is true should be equal to true. So now if I go through here and I run this, it gets through all the way to 19, it gets through to 17, hits 19 and errors because I didn't have 19 hard-coded in my list of primes. So then here it says assertion false is not equal to true. Which what that means is I called is prime and I got false. So then I passed false and as my first argument here. And I got false is not equal to true. The main point I wanted to cover here is that you can, once you start running the code on your own computer, continue to test different cases for your code without having to do a lot of work to get them tested, because what is in the Runestone book may not always be available to you. And assert is something that is often done at program startup time. So say you had a web server that was going to go and serve a website to your users. So you had a healthcare website that was going to serve a patient portal for people to log in and manage their health information. There may be a number of checks you want to make sure are accurate whenever you start up your server. So you might do an assert, which will immediately keep your website from starting. So say you forgot to update the version of your website and you know that it should be on version 11, but for some reason, whatever version you're running, version 9, you can assert and it won't launch it so that you're not showing any incorrect content to your users. So in a real program, assert would be used as a way to ensure that your program does not continue running because it would no longer at that point be considered a valid program. So if there are no questions on testing, sort of testing your own code. Then we will go and break out into the bug studio, which everyone should have. So the bug studio, I'm going to give a fair amount of time to work through that because it is kind of confusing. That's the wrong class. If you haven't done it, and if you haven't written a lot of code or have not had to work with a lot of other people's code, finding bugs, actually really fixing bugs and other very difficult, especially because most of the time you may not know all of what the other person's code is doing, so you want to make the minimum required change to continue working. So in all of these examples, so in all of the studio, there are 2 to work through here. Well, now there's 3. So there are a few to work through. I'll go through this first walkthrough. Try to change as little of the code as possible. You may be able to tell what it's supposed to be doing, and you could rewrite it entirely. But that's not the goal of this studio. The goal of this studio is to get the person's code to do what it should be doing with the least amount of change possible. So in a lot of cases, that smallest amount of change is changing like 1 character from a plus equals 1 to a plus equals 2, or realizing that they have a return inside of a for loop that's going to leave the function immediately. So you may then need to keep track of that value. So in this case, what we want to do, it's launch code Scrabble. So it calculates the value of the score. Q's are worth 10 points. So what this checks is that for every word they create with a Q, it's saying that the value of that word is going to be Q for each Q in the word, but the second letter must be a U. So in this case, this person gave the word dog, which is a valid word. And what indicates it's not a valid word is that it starts with Q, is not immediately followed by a U. That is the assumption in this program. So we're assuming every word earns points. So every letter is worth 1 point, except Q's are worth 10. If at any point you attempt to create a word that is a cheating word, which means you did Q followed by something that's not a U, you get 0 points altogether. Otherwise, you keep getting 1 point for each one of the words in your list of words. And keep going forward. So what's happening here is this says that if the word, we go through here initially, we go for every one of the words in your list of words. When you don't say, you automatically earn 1 point for this word. So you start off with 0 points, you then get to go to 1 point, and then we check, is the first character in this word a Q, and is the second character in this word a U? If it is, we assume it's a valid Q word. So it starts with Q. That's what earns you 10 points in this slim down edition of Scrabble. So then you take points and you add 10 to it. Otherwise, you return 0. So this is wrong on 2 accounts because the words are supposed to be worth 1 point, and words that start with Q are supposed to start with 10 points, so it's wrong in both test cases. So this test case, for the word quiet, you get 11. The other one that is valid, you get 0. And part of the reason for that is that no matter what, it's going and adding 1. So we know we only want to add 1 in the event so we know if it starts with Q, we need to go and do something else. So in this case, we'll just say we're going to do something else. I don't know what that is yet. Pass in Python just means don't do anything here. So we know if it starts with a Q, we're going to do something special. Otherwise, else, we know you didn't start with a Q, but you're a word. So we don't want to return there. We want to say, okay, you didn't start with a Q. So we moved the logic of earning a point to be after the case that we know your word started with a Q. And then the next scenario we know is that if it starts with a U, which means it's valid, we know that it's worth 10 points. Otherwise, that is where we return 0 because we know that they cheated. So now if we run, missing the colon. So now this is correct. We end up getting the 1 and we get the 10. So I will click save here. If you look at the original set of code, the logic that I changed was not very much. I'm doing everything that this is currently doing. So it returns 0 at some point. We know at some point we will need to return 0 if they cheated. We know at another point we need to check to see if the word starts with a Q. We also need to know if the second letter in that word is a Q. If it starts with a Q and a U, we know we need to add 10 points. All other words earn 1 point. So the change here is that I went and said, all right, if it's a Q, which was already checked before, then we know we need to check the next letter. If the next letter in the word is a U, 10 points, otherwise none. Else, increase the points by 1. There are other ways to do this to keep it more similar to what is here. And if other people want to figure out or show later a way to make that less of a change, that's the way that makes most sense to me, which is why I did it that way. So then the 3 to work through are these ones. So each one of these explains what they are. So you'll need your laptop and the studio open. order to do them. First one is not printing out the correct characters for what's in the list, because it should print every character that many away. So it says every third character, so it should print the first one, and then 3 later, which is 8, and then 3 later, which is 9. It's not doing that. This next one is for the ages. So return true if every member of the group is at least 70. Otherwise, return false. So you need to check to see if everyone in your group is less than 70. And then correctly return if everyone in the group is less than 70. It's doing it incorrectly for the first group. So there's one person under 70, but it's saying everyone is under 70. So that is the bug there to look at. Then on this last one, the password checker. Has bad input on line 7. That generally means there is something incorrect with the syntax somewhere in here between lines 1 and 10. So try to figure out what is wrong on this one. I think this one is the trickiest if you are if you haven't done a lot of programming, especially if you haven't done a lot of programming in Python. All right, everyone get started. I'll give you about 30 minutes to go through it, and then we'll meet back and cover it. If you get done with these, feel free to move on to Monday's reading or the assignments that are due Sunday night.
So, that's what I'm in. So this was kind of tough, this last one.
Specifying how far to skip. It's calling I the parameter. Then I is being overwritten inside the loop.
I need a hard time in true equivalence.
That was the second one.
Did you get the second one? Inside. Yeah, I think it's. Third one, anything else? Yeah, I don't know if I would have gotten that last one if I didn't get the nice little error telling me where to look.
You get all.
Okie doke. We will work through these. Has everyone had a chance to give these bugs a whirl? Has everyone solved them? So in this case, where it's not printing the correct number, what would help solve it? You can just shout out answers, or just like write them on a piece of paper and you can throw it, or not. So it may not have been obvious. So now when I run I'll refresh the page. The bug here is that I is redefined in this for loop. So this parameter here that is called I gets redefined inside this for loop. So every single time that it's iterating over this, we go and we print I as well as counter mod I we get very peculiar behavior because we are effectively mutating the value we passed in as we go over this for loop. Wait. Oh, I see. Let me see if I can get it on there. Is this the right? Is that right? Okay, it is working on the Chromecast. So the problem here is that this variable I has been redefined within this for loop. If you remember, every time you go over a for loop, you have what's called a scope here of I. So what happens is for each number in your nums, you're going through and you're saying I is assigned the value of whichever one you're currently grabbing. So the first case, you're saying I is assigned the value of 4. So when we do counter mod 4 equal to 0. What we really want is what we passed in. And the problem is that we redefined and reused a variable we should not have reused. So if we properly go over our values and then we print out the index at that point, we only get 489. So that's sort of the smallest amount of change you can make there to get the result that is desired, which is print out 489. So the problem here, which is very common, is accidentally redefining a variable. So this next one is another common mistake that happens. So the whole problem is here in this check group. And what happens is it says, all right, so for every age that I've been given in my group of ages, the list of ages, I'm going to go and take that age, and if it's less than 70, I'm going to go ahead and say that return false. When what it is supposed to do is it's supposed to return true if every member of the group is at least 70, otherwise return false. So in this case, it's going to go ahead and say, all right, the first age I go through, first time, is that age less than 70? No. Then return false if you're less than 70. Return true if you're greater than 70. But the problem here is for the list of ages. So down here where I have 78, 71, 25, and 84. I take 78. I grab 78, I compare it, 78 is greater than 70, and then I immediately return true. So what's happening, so sort of a debugging step that would be common to take is to print out the age here. And what you'll find out is you're only ever getting the first age in your group. And the reason for that is because you have a guaranteed return every single time you go through this for loop for the first time. Because when you have an if and an else, one of their bodies will always be executed when the if and else are matched up like this. So no matter what, we're either returning true or returning false based only on the first age in our list of ages. So what you really want to do is you want to return true if you've gone and checked every single age in your list. So you know at any point that you're less than 70, you can return false. So we can go and try this one out. So now we know it passes for 2 of the cases. But we're no longer returning true at any point, but we now know it passes for the two cases where we have people that are less than 70. So we know we handle the case of having someone in the group that's less than 70. So now what we can do, so what this means is someone in this group was 70, so we returned false. What you want to do then is you know at the point that no one is under 70, you return true. So before what it had, so in this case, now everything passes. Before what happened is this was within the for loop, and within an else inside that for loop, so it prevented the for loop from actually going over each item in your list, which in this case was getting each age in your ages. This is also a fairly common accidental occurrence, is to return too early. And that's where doing things like putting a print statement inside just to see what's happening often helps. So saying something like current age, running it, and realizing you should put a comma. But seeing each value as you go through is very helpful. Whenever you go to say your program's finished, of course you'll remove your print statements. Then you'll run it, everything will pass, and you're good. This last one that gives this bad input on line 7, parse error. So parse error in Python, it wasn't even able to read your entire file. So it's not just a syntax error. Syntax error happens when it can read through your entire file and it discovers you did something wrong in that file. A parse error means it was not able to get even finished reading your file. So in this case, it's telling you right where it could no longer read. So you know something has to be wrong with line 7 or before because that parse error happened on line 7. Most often, it's going to be on the line where it said the error was. So in this case, what is the problem?
else if.
Yes, so else if. So in Python, that's elif. The reason that else doesn't work here is that else does not accept the Boolean operator, the Boolean expression afterwards. If you're going to have a Boolean expression, you must either have that Boolean expression after the if or after an elif. So then here, you go and you run, and it goes, you get the false and the true that was expected. Now what you could have done is completely rewritten this and satisfied the requirements for the password checker, but in a more realistic code base that is larger. Often, you don't have enough information to know that your change is going to produce the same results to everyone who's using the function, which is why anytime you go to change generally what's called untested code, these things down here to verify it works, or code that's not fully tested, you want to make the smallest change you can to produce the correct results so that you don't break functionality unintended. So if you notice there's a bug somewhere in the code, usually what you want to do is make the smallest change you can to produce the correct functionality. Mark is completed. Done. Remember, Sunday, there are 2 assignments due. And a lot of people have already gotten Python running locally, which is great. Feel free to submit questions on Piazza if you're having problems and you run some Python code on your computer and then you go to upload it to Vocarium and there's a problem. The correct, well, I won't say correct. The more approved approach from Launch Code there is to send a private message to the instructor and or teaching fellow for your class on Piazza with your code so they can check it out and see why it's working locally on your computer but not working on Vocarian. And that way, no answers are incidentally shared within a class or across classes. We are actually one class ahead now of the other classes because they're doing gala tonight in St. Louis. So that's something else that you may or may not notice in the Slack channels. The content covered in each class will not necessarily be the same going forward. And good job. Most, I think, on average, everyone was here right around 5:45. We got here early. Keep that up, or that's the earliest. Because the doors won't be open until then for us to be able to come in because we can't guarantee the space. And if you could help me out whenever you leave, if you have moved a chair from somewhere, can you put that chair back where you got it? That would be appreciated. If you have any questions, feel free to ask me or a teaching fellow. But that is all for this evening.